it to Friday. All right, we are still working with fractions. I know that gets you excited on a Friday. But at least today we're dividing fractions. We're not just simplifying fractions from our word problems. Okay, today we're dividing fractions, and we've done that in the past. Let's look at number 1. A glass pitcher holds 6 1/3 cups of pineapple juice. Tracy transfers the juice in equal amounts into 3 bottles. How many cups of juice will each bottle contain? Well, if I have 6 1/3 cups altogether, and I'm dividing that into 3 bottles, I'm dividing it up into in 3 different bottles. Okay, this mixed number. Okay, we've dealt with those before. Remember, we turned them into an improper fraction, meaning bigger on the top. And we do that, remember, we multiply diagonally and add the numerator. So 3 times 6 is 18, plus the 1 is 19. And it was thirds, so it stays in thirds. And then we know that anytime we have a whole number, it's the same as placing it over 1. So this is the problem that we have to work with, okay? Now, that looks like something we've done a million times, doesn't it? All right, so we know that when we're dividing fractions, we slide the first fraction on over. And then that second fraction, remember what we do with the second fraction? We flip or find the reciprocal. So 3 over 1 is 1 over 3, and then we multiply. And we simply multiply straight across. 19 times 1 is 19, and 3 times 3 is 9. So how many cups of juice are going to be in each bottle? Well, 19/9. Okay, that doesn't make a lot of sense, does it? So let's turn that back into a mixed number. And we've done that before. We just do it like we read top to bottom. 19 divided by 9. We know that 9 won't go into 1, so there's our placeholder 0. And from our math facts, we know that 9 goes into 19 2 times. 2 times 9 is 18. And we subtract, and we have 1 left over. So we have a remainder of 1. All right, so now we know that we have 2 whole cups. We had 1 left over, and we were dealing in 9ths. So 2 1/9 cups will be in each bottle. Now that makes a lot more sense than 19/9, doesn't it? Okay, we know they're both the same number, but this is easier to talk about when we're talking about cups of something. Okay, number 2. A recipe calls for 1/4 of a cup of sugar to make a chocolate mug brownie. And if you've never made chocolate mug brownies, I know that sounds crazy, but you can make them in the microwave, 1 cup at a time, 1 mug at a time, and they're really, really good. I'm gonna have to make some of those one time and bring them to school. Okay, the recipe calls for 1/4 cup of sugar to make a chocolate mug brownie. How many mugs of brownies can be made with 1 3/4 cups of sugar? Well, I'm pretty sure in 4th grade, y'all learned what 1/4 of a cup was, but just to make sure, let's think about that for a minute. Let's think of it like money. That makes it easy to think of. If I had 1 whole dollar and I was dividing that into quarters, how many quarters would I have? $1. Oh, I'd have 4 quarters, wouldn't I? Okay, so when we're talking of, if we say 1/4 of something, 1/4 is 1/4. Okay, so 1/4. So we know, let's see, that 1 3/4 cups, and each recipe calls for 1/4 of a cup. Okay, now, all right, we just did one like this. we have a mixed number, and we know that we can turn that mixed number into an improper fraction. We multiply diagonally and then add the numerator. So we have 4 times 1 is 4, plus the 3 is 7. And we were working in fourths. So now we have 7/4 divided by 1/4. Now that looks a lot more like we've been working with, doesn't it? Okay, so we know when we're dividing fractions that we slide the first fraction on over, so we still have 7/4. And then the second fraction, we flip the reciprocal, so we would have 4/1, and then we multiply. So we have 7 times 4 is 28. 4 times 1 is 4. Okay, so we can make 28/4 cups of brownies. Well, that doesn't make a lot of sense, does it? So, math facts, 28 divided by 4, I can make 7 mugs of brownies. All right, number 3. Okay, number 3. Sean and his sister Betty equally mow 8/9 the total area of a lawn. What fraction of total area did each of them mow? Well, they mowed 8/9 all together, and if we divide that between 2 people, okay, now we know when we're dealing in fractions, anytime we have a whole number, it's the same as placing it over 1. So we would slide our first fraction on over, and then the second fraction we flip, or we do the reciprocal. So the flip or the reciprocal of 2/1 is 1/2, and then we multiply. So we have 8 times 1 is 8, and 9 times 2 is 18. So let's see, is there anything that we can divide both of those by and simplify this? I'm going to try a 2. 8 divided by 2 is 4, and 18 divided by 2 is 9. Okay, so now that's a smaller number. Is there anything that I can divide 4 and 9 by and get a 0 remainder? 1 wouldn't change anything. 2 doesn't work with the 9. 3 doesn't work with the 4. And 4 doesn't work with the 9. So there's nothing else I can try. So each of them mowed 4/9 of the total area of the yard. All right, number 4. Jane eats 2/3 of a cup of cereal every day for breakfast. If the box contains a total of 24 cups, how many days will Jane take to finish the cereal box? Well, she has 24 cups of cereal that she's dividing and eating 2/3 cup a day. So that 24 cups is being divided by 2/3 cups per day. Now, we know when we're dealing with a whole number, we look at it like it's over 1. All right, so now we're just dividing fractions. So we slide the first one on over, and we flip or do the reciprocal of the second fraction, and then we multiply. So 24 times 3, well, I'm not real sure about that, so I'm just going to go to the side and do the math. 24 times 3, because it's easier when we stack. So 3 times 4 is 12, and I carry my 1. 3 times 2 is 6, plus 1 is 7. So I have 72, and then 1 times 2 is 2. So 72 seconds, or 72 halves. That don't make a lot of sense, does it? Because we're talking about how many days. So let's see. But if we go to the side and do, just like we read it from top to bottom, 72 divided by 2. 2 goes into 7 3 times. 3 times 2 is 6. And if I subtract, 7 minus 6 is 1. And I bring down to my 2. And 2 goes into 12 6 times. 6 times 2 is 12. And if I subtract, I get 0. So I have a remainder of 0. So now I know that that box of cereal, if she only eats 2/3 cups each day, will last her for 36 days. Okay, number 5. Lucy bought, oh, forgot to erase. Lucy bought 9 1/3 pounds of blueberries from the farmer's market and placed them in equal quantities in 7 bags. How many pounds of blueberries does each bag hold? Okay, so she had 9 1/3 cups of blueberries all together, and she divided that up into 7 different bags. Okay, we have one of these mixed numbers again, and we already know it's easier to just go ahead and turn that into an improper fraction. So 3 times 9 is 27 plus 1. So we know that that's the same as 28 over 3 because we were working in thirds. And we also know that when we have a whole number, it's just like putting it over 1. All right, now we're set up in a standard fraction division problem. We know that we slide the first fraction on over, so 28 over 3. We flip or get the reciprocal of the second fraction, and then we multiply. So 28 times 1 is 28. 3 times 7 is 21. So 28 21ths, 28 21sts goes in each bag. That doesn't make a lot of sense, does it? So let's think. Oh, I can divide that. 28 divided by 21. Well, we know it won't go into 2. 21 will go into 28. Well, that'll only go one time, won't it? And 1 times 21 is 21. And if we subtract, we get 7. 21 won't go into 7, and there's nothing else to bring down, so I have a remainder of 7. So now I know that I have 1 whole pound with 7 left over, and we were dealing in 21sts. So each is 1 and 7/21 pounds. Now, let's look at that and see, is there anything that we can divide both of these by and get a lower number with no remainder? Okay, 2 doesn't go into 7 or 3. Let's see, 7. Oh, quick math facts. I know that I can divide each one by 7. It doesn't change this whole one, does it? We still have that whole one. 7 divided by 7 is 1. 21 divided by 7 is 3. So how much would go in each bag? 1 1/3 pound. Okay, since it's Friday, we're not going to do 3 sheets. We're only going to do 2. So we've done the first one together. And I'm going to leave you guys to do the second one on your own. And turn that in to me. And I'll see you guys later. Bye-bye.